Hello everyone, in this video we'll be solving a paper 2 problem for IB chemistry. This problem comes from the 2022 paper focusing on organic chemistry and also redox reactions. Magnesium is a reactive metal often found in alloys. Magnesium can be produced through the electrolysis of molten magnesium chloride. Write the half equation for the formation of magnesium. So the product will be magnesium, and we want to write a half equation. So you can use the periodic table to solve the problem. So because magnesium is belongs to the second group, it's gonna have a charge number of 2+. So here it needs to lose 2 electrons to become magnesium, right? And because we usually don't write negative sign on the left hand side, we'll remove the minus 2 electron to the right hand side. So plus 2 electrons. And this is the half equation for the formation of magnesium. Suggest an experiment that shows that magnesium is more reactive than zinc, giving the observation that will confirm this. So magnesium and zinc. So one method we can use is we can react both elements. So react magnesium and zinc with nitric acid, right? And you will see that magnesium produces or forms bubble at a faster rate. This will suggest that magnesium is more reactive than zinc. Organomagnesium compounds can react with carboxyl compounds. One overall reaction is this. State the name of compound A, applying the AUPAC rules. So the first thing we need to do is we need to see how many carbons is in this compound, and it has 3 carbons, which is all on the longest chain. So here is the longest chain, right? So 3 carbon on the longest chain, which give us the prefix of pro or propane, right? And then we need to think about the functional group. So you can see that a oxygen is connected to a carbon atom with a double bond, and this is the ketone functional group, which has the ending of ONE. So here you have 3 carbon and a ketone functional group. Then combining the prefix with the functional group's ending, it will be propanol. So this will be the answer. Identify the strongest force between the molecules of compound B. So here you can see that compound B has an OH, which belongs to the alcohol group, and this is a hydrogen bond. And hydrogen bond is the strongest force between molecules, because we know that for all intermolecule forces, hydrogen bond is the strongest attraction force, right? Compound B can also be prepared by reacting alkene with water. Draw the structural formula for the alkene required. So here we have the functional group, hydroxyl, and the longest chain has 3 carbon with a substitute of methyl. And for the for alcohol formation, we know that it will be an alkene plus water to form an alcohol, right? And this process is known as hydration. If you are not familiar with this, go back to your note and check if you understand this. So alkenes, they gotta have a double bond first, and then they have one methyl and another carbon connected to the longest chain, right? So how can we do this? Well, we first know that if it has another group, it's gonna be here, CH3, which is the group right here. And then they have a substitute, which is gonna be here, right? And for the rest, it will connect to hydrogen. So this will be the structural formula for the alkene required. Just to make this thing looks more natural and more beautiful, I'm gonna switch this a little bit. So you have a double bond and another carbon connected to the longest chain and a substitute group, and then two hydrogen carbon. And when this alkene reacts with water, what happens is the double bond will break, right? The double bond will break so that it has an extra bond to connect with the alcohol group. And this is known as the hydration process. Deduce the structural formula of the repeating unit of the polymer form from this alkene. So basically, when you are drawing the repeating unit, the double bond will disappear and it will become a single bond. And then it will have two extra bonds here to show how this molecule connects with another unit. And then you have two hydrogen here as usual, and then two CH3, and then a N here, just to show that this is a repeating unit. Deduce what will be observed when compound B is warmed with acidified aqueous potassium dichromate. So you should be familiar with this. This is often used as an oxidizing agent, which is frequently used to identify alkene and alkyne. Identify alkyne and alkene, right? And we know that compound B is an alkyne. So let me write this down. Compound B is a single bond, so it will be an alkyne, right? This tells us there will be no color change. So if is an alkene, if a compound is alkene, meaning that it has a carbon double bond, then the color will change from orange to colorless. Identify the type of reaction. The reaction is shown by this equation. So here you can see that apparently those two elements, they switch places, right? So I is being replaced by OH minus, and this tells us that this is gonna be a substitution reaction. And because this element here, I minus, is a halogen, it's gonna be a nucleophile. So the answer will be a nucleophilic substitution. Outline requirements for a collision between reactant to U product. So basically energy in the reaction needs to be greater than the activation energy. So this is the requirement for collision. The polarity of carbon halogen bond attacked by HO minus, outline giving a reason how the bond polarity changes going down group 17. So polarity going down the group. So polarity decreases, right? So remember that polarity refers to the ability to attract a shared pair of electrons. And this tendency in group 7 decreases as you're going down from this group. And this is becomes, when you're going down the group, right, the number of valence electron remains unchanged. However, atomic radius increases because the number of electron shell increases, and this causes the attraction force on valence electron to decreases. Therefore, as you're going down group 7, the polarity decreases. And this is the answer for this problem. You can also use the data booklet and compare their polarity, compare their numerical value. This method is accepted by Marxing as well.